is random linear network coding? One of the difficulties, I think, is that people generally assume that randomness is something that one wishes to avoid rather than use as a design tool. It seems somehow what I tell my students is a slacker approach. And if you can get away with it, you absolutely should. What's interesting is that it's not just a slacker approach and you can get away with it, but it's provably optimal. So for instance, suppose that I have a peer-to-peer system. People are familiar with BitTorrent, but there are many other such systems. Many of them, incidentally, are not just peer-to-peer, but are actually commercial managed systems that happen to operate as peer-to-peer systems. Suppose that I need 10 pieces to reconstruct the movie I wish to watch. So it's very much like trying to assemble maybe a collection of baseball cards. It's the same principle. So beginning, when I start my baseball card collection, I have nothing, and the first card I get is bound to be a new card. I'm so happy. The second card I get is also bound to be a new card. When I meet somebody, it's likely that I will get a card that I don't have already. The problem comes right around when my collection is not quite complete, but close to complete. So if you have a collection that is close to complete, but not complete, when you meet a friend and you say, hey, what baseball cards do you have? And he shows you, and you compare the cards, it's very likely you will have the same cards, that there are really no opportunities for you to increase your collection in any way. That's called a coupon collector problem. So there's a description, a mathematical description for that, somebody collecting coupons, whether it be baseball cards, stamps, whatever collection you have. And if you do coding, then what happens is that that phenomenon that occurs towards the tail of you constructing your baseball card collection never kicks in. Everything that you see is new, because everything that you see is a new equation based on the original cards. And the way to ensure that novelty is through random choice of ponderated coefficients in those equations. So that's the basic idea, and you can see right away then why it's so attractive for storage. It permits having a very efficient calling of data. It allows you not to have to keep track of everything. Otherwise, you need very sophisticated tracking. So that approach to managing data by making random collections of it is quite powerful. The other thing is that you can take two randomly mixed things, randomly mix them, and immediately get a new randomly mixed thing. So whenever you have a dynamic setting, such as is increasingly the case in wireless systems, and particularly with the emergence of what people call the Internet of Things, which really means highly dispersed, largely self-managed, standalone wireless networks, that problem of not being able to keep track of everything and being able to allow it to be managed independently is one that's, of course, of growing importance.